Hey guys, welcome back to another episode. We're going to do like a part two. Last week we talked about some of the wiring. We're going to continue on with that this week, and going to have a look at some of the different plugs we're going to use and some of the tools you're going to need to terminate those plugs. Probably the most common plug that you're going to see is one of these bad boys. Hang on, let me find one on the car. Right here. This is a Deutsch connector DT style plug. These particular ones here have a current rating of about 7.5 amps per pin. Something that you got to keep in mind. A lot of people just think Deutsch and they whack them on spotlights, and before you know it, they got plugs melting out. So really important to make sure that you do look at how much current you're going to be putting through these plugs. You can actually get a bigger plug. I've got one sitting in here. It's also a DT style. Where those plugs go so you can compare the size. Alright, so there you go. So it's a lot bigger. Okay. This plug, it's basically the same style plug, still a 2-pin plug. This style plug here in the bag is rated for 25 amps per pin. Okay, and when you have a look at the pins, they are beefy. I think they'll take up to a 12 gauge cable as well, so 12-14 gauge is probably what you're going to be looking at using on a short run for 25 amps. Probably not short with a 12 gauge, but because you could probably get away with a 16 gauge for 25 if it's really short. But yeah, so Deutsch connector, keep an eye out. Most Deutsch connectors are the 7.5 amp pins, so you do have to keep an eye on that. These connectors are so good. They're super easy. Super easy to put together. So yeah, basically comes in, let's just pull one apart here. So you have 4 main pieces plus the pins, and you'll have male pins and female pins. So now another thing to note is these are genuine Deutsch over here. These ones over here are just Chinese Deutsch, and the main difference is the pins. So these pins here, they're an open barrel style crimp. If we can see that, just there. Okay, open barrel style crimp. So you'll need an open barrel style crimper to terminate them. Whereas these pins here, these are basically a billet, and you need the proper Deutsch crimper, which crimps in 4 places at once. This is a Deutsch crimper. Now, something that will catch a lot of people out is these come in different sizes. Now they all look the same, but they're only good for certain size or certain gauge pins. So these pins here, these are for up to a 14 gauge cable. I think it's like 18 to 14, something like that. And the pins on one of these, I think it's called a DT25, the big 25 amp ones. These pins, let me pull one out. They don't actually fit. They won't fit this crimper. So, something to keep in mind. Alright, there you go. So, you can see the difference in size there. Okay. That's a 25 amp pin. That's a 7.5 pin. They're not even. I'm not even showing you apples for apples there, because one's a female, one's a male. But you get the idea. So yeah, those 25 amp ones won't fit in this crimper. When you terminate these, basically you'll strip your cable. It goes in the end, which on this case has got the little green mark on it. I don't know if you can see that. Yeah. So this is the end that gets crimped. The pin goes in there like that, and you just pull down. And when you pull down, see if you can see this. You see, I don't know if you can see that. There's 4 jaws in there that come in, so it actually crimps in 4 places at once. And then depending on what pin you've got, this is actually depth adjustable, so you can adjust that so you can make sure you're getting it crimped right on that green mark. You basically crimp your pins, push them into the end. I really should terminate one for you. What can I... No, I'm not going to. Maybe I'll do one later. I haven't thought about doing that. I didn't plan it. This is on the fly. Sorry guys. We're not oh, camera thing's having a sad. There we go. Yeah, not going to terminate. But, you know, crimper number 1 right there, Deutsch tile. Look out, because different sizes. This one's good for the 7 amp ones. The 25 amp ones look similar, but basically the hole in here is a little bit bigger. Okay. Getting back to the open barrel crimp style, right? You're going to need a open barrel crimper. Now I've got 2, and I'm just looking for my other one. Alright. So obviously you can spend a lot of money on crimpers. Or you can spend a little money. So this crimper here, this is a reasonably priced ratchet crimper. You need one of these to terminate all of your GM type plugs. Trying to think what the actual term is for them, but most of them are open barrel style crimp. And like you can see on here, this particular crimper, it's good for 18 to 20 gauge and 14 to 16 gauge. Okay, it's really important that if you're using a 14 to 16 gauge cable, it's really important you put it in the right hole, otherwise you're going to over crimp that cable, possibly break the strands. So yeah, this really nice crimper. A little bit expensive. I think they're about 160 bucks or something. And then you've got this one here. There's also an open barrel style crimper, very basic, not ratchet, doesn't have a ratchet on it. However, because the jaws are quite narrow, it is quite helpful to have this. I'm only really using this on some of my joins where I've got to tee into cables, because I'm using another misconception which always causes a lot of debate is when joining into cables, do you solder or do you crimp? To solder or crimp, that is the question, right? Well, I'm here to tell you the answer is to crimp. Okay, so depending on the size cable or how many cores you're trying to stuff into a tee-off, okay, you're going to get different styles of these open barrel splice crimps. This is another style down here, which is a lot smaller. Okay, a little bit difficult to find. These ones I got from Ep18, which is an online company. But obviously, this particular open barrel splice, I can't fit in my nice expensive ratchet crimper. It doesn't fit in there properly. Plus, because it's got the stopping block on the other side, when you're doing a splice, generally you've got cables coming in from both sides, so this not really any good to me, doesn't really help. So I have been using this, and then because I'm not a huge fan of this, I generally get it started with this, and then I whack it in this crimper, which is also an open barrel style crimp, but it's not really designed for it. It's more for crimping ferrules, bootlace ferrules. I don't know if any of you are familiar with them, but yeah, this does a great job of crimping it, but I've got to get it started with the cheap crimper first, otherwise the ends don't roll over how an open barrel crimp should. So yeah, so we've got this style crimper, we've got this style of open barrel crimper, we've got this style which is more to terminate the GM plugs, which are where are all my plugs? This kind of stuff here. So, you know, from memory, man, it's been a while, I can't remember, but this kind of plug, this style, you know, like temp sensor plugs, all designed for this. So when I go and do my engine loom, I am replugging. I just can't remember any of these plugs. So it's probably all written here. Here you go. So let's just get rid of that. So these are all GM, so you've got crank angle sensors, O2 sensors, your map sensor, TPS sensor, stepper motor connector, Delco 3-pin sensor plugs, coolant sensor plugs. It's all there. They're roughly between 12 and the LS coil loom plugs are very expensive. They're $22 each, but every other plug's about between $8 and $15 each, right? I got them from I don't know, I might have to edit that out. I think it had my address on it. But basically, I got them from EFI Hardware. Not sponsored by them in any way, just a bit of information. Yeah, so got all the plugs from EFI Hardware. I think to do all the plugs for the LS motor, it was about $500 delivered. What else we got? There's another crimper that you'll probably have seen before, and it's just standard red, blue, yellow. So for doing crimps on things like this kind of stuff, real simple, because obviously whack the yellow in the yellow. If you've got a blue one, blue in the blue. So these kind of terminal like lugs or connector styles, I'm just using this kind of lugs on the car. I'm not using any of the forks or connectors. Yeah, so you've got that, and then for anything bigger than that, you're going to need a heavy duty crimper for doing battery lugs, and they're very expensive, so you're best off seeing if you can get someone at maybe the battery place or whoever to just terminate them for you. So yeah, there's some of the plugs. You've also got this kind of stuff available. This is another Deutsch product. These are called bulkhead fittings. So down the bottom there, that's a 3-pin bulkhead fitting, and the top one's an 8-pin. Good for moving through, say, a firewall, or even if you're going from a sealed enclosure. Say you got a box with your ECU inside of it, for instance, and you wanted to just have a plug that plugs into the side. That's another good option for doing that. Again, these are only rated for 7.5 amps per pin. And then you've also got, some of you may have heard of mil-spec harness plugs, which is this kind of bad boy right here. So this is actually a bulkhead mil-spec fitting. It's a 42-pin plug. I've got a feeling from memory these are a 13 amp pin. But basically, it's a BC style connector. These are fully submersible, watertight. They have gold terminals. They are extremely expensive. Without the boots, the sealing boots that come with it, which don't come with it, you got to order them separately. Without the boots, that plug's about 350 bucks. They're generally used to go on the firewall. So normally on your engine loom, so people can have their loom attached to the engine, just have a plug on the firewall, and say if you want to rip the engine out, you can just unplug from the firewall, leave your whole engine loom still loomed and cable tied, or however it's fixed to your engine. Leave it all on there so you're not mucking around with it. Just unplug the firewall, rip the motor out, job done. So that's generally what they're used for. I am not convinced I'm going to use it. I think I'm going to try and, I've got 2 of them and I think I'm going to sell them. For a few reasons, but I don't like the fact that I know that I think it's either 7 or 13 amps, and that's probably enough current for the injectors and the coil, but I don't know. I've got to think about that a bit more. I brought a boot and I was going to put a gland, which, you know, most people would probably use the old cheap option. I don't even know what I've done with the boot, but it doesn't matter. So yeah, what else we've got? So we've got the so they're the plugs, they're the crimpers. Basic setup on the car. We've got the PDM in here. This is basically like a giant fuse box, but an electronic version of one. It's got the fuses built into it. It's got all the relays built into it. It's got 30 channels, but it does have a maximum current. So even though there's 30 channels, 20 of which are 10 amp and 10 of which are 20 amp, so that's 300 amps for those that are doing maths at home. You can only actually switch 125 amps at any one time. So because of that, you've got to be aware of what you're doing. On a truck like this, most cars you'd probably be right with 125 amps. But when you start getting into race applications, where you know we've got down here you can see these are our transmission coolers. Each cooler's got a fan. Then you've got your radiator. The radiator's got 2 fans. The fans on the radiator, on startup, they can pull like 54 amps. So you can see down there, I've got that little red box underneath the radiator. That is a MSD solid state 4-channel relay. So that relay is actually running my 2 fans. So that load is not coming off the PDM. Because if they came on while everything else was running, we would far exceed that 125 amps. And then down here, I think it's around here, I've made up this little bracket because I kind of overlooked this while building the car. I did pretty well with everything else. So I've made up this little bracket. This is going to sit in there like that. It's just going to run a hose clamp to hose clamp it in, and then off that bracket we're going to have this little neat fuse box that it's really a relay box, right? It's not watertight, but it does have a little enclosure to keep, you know, most of the crap out. And in here I'm gonna put some other relays and fuses which will be switched via the PDM, so they will be controlled via the system which we can program, but they will be standalone. And one of the reasons for that is A, we were running out of capacity on the PDM and I didn't want to buy another PDM, and B, the ECU specified that it needed to be switched via a special relay which has a diode in it, and that's to stop voltage spikes in the case of a fault, which could potentially do serious damage to the ECU. So very important to put that protection in. So because of that, but it's going to work out good anyway. So even I'm just going to, so that's what these 3 main ones here, these are what's going to be feeding that fuse box. They're way bigger than they should be because they're only actually gauge 10, I think. Yeah, 10 gauge. But they're silicon insulation, so it's got 200 degrees Celsius temp rating, which kind of wasn't needed, but for that run anyway. But yeah, some of the cables are going to come down, probably not. I think some of these ones here are going to come down into here, into the fuse box. And basically that fuse box, the fuse box or the relay box, that's just going to switch the like I said, it's controlled via the PDM. So the PDM is going to tell the relays to switch on and off, and the relays that are going to be down there, we're going to have like the blowers, the helmet blowers, the 2 helmet blowers, and let me just have a look on my move some of this stuff out of the way quickly. My mini, here's my mini version. This is my schematic of the wiring on the truck. So put that there. If I tilt this down. So these, what is it? We've got 1, 2, 3, 4, 5. So these 5 relays are going in the relay box. So coming from our solid state isolator off the 40 amp supply, which only requires a 20 amp, this is our special diode protected relay, and this sends the power, this supplies power to the injectors, the ECU, and there's 2 that goes to the ECU. One's basically just a message telling it that, hey, yes, the relay's turning on, and the other one, when it gets that message, the ECU then switches this pin to ground, which then gives it control over that ECU, over that relay. So in a situation where you're just turning the truck off by the key, and you go and say, hey, we're going to turn the power off now, basically the ECU will have control, and it will shut itself down after it's done its critical checks, like record the latest data log, or any TPS, or what do you call it, throttle body calibrations that it might have to do before it shuts down. It will go through all that process and do that before it kills the power to itself. But in an emergency situation, when we kill the power to our solid state isolator rather than turning it off at the switch, it's just going to go dead straight away, and you'll obviously miss out on all that that log information. And then our other 4 relays are just standard relays. They're just going to be controlling the power for our roof lights, which is our we've got some big spotlights if we do any night racing. The light bar, which goes on the front, obviously our helmet blowers, and then we've got our accessory relay, which off that we're going to have our CV radio, our intercom. I've got dash in here, but the dash doesn't actually get power because we're running the VNet. It's powered by the VNet. That's only if you're not running VNet to the dash. If you're running the dash as a standalone, you would need to give it some power, and then also you do have to send a 12 volt. Again, I'm not sure whether we need that, but that's basically, the dash can put out a 12 volt. It switches a 12 volt output for a warning light, an external warning light. Obviously you've got warning lights on the dash itself, but you can actually, it's got an output to turn on an external light, whether it be a shift light or something like that, and you should give it a designated 12 volt feed to switch for that. So that's what that is. But yeah, that's some of the relays that we're using in that relay box. What else have we got? Yeah. So anyway, that's roughly about it. Anyway, guys, it's about where we're up to at the moment. We're doing lots and lots of heat shrinking, lots of terminating of plugs. Obviously, PDM's mounted in here. The Mtron ECU is going to get mounted up into here, and then from there, obviously that's going to control most of the engine and also a lot of the sensors on the car. One thing to if you are doing your own loom or your own wiring, when it does come to wiring any sensors, just be real mindful. Some sensors require a sensor 0 volt. Now that does not mean you wire that 0 volt to the frame. You'll find that your ECU will have a 0 volt output, and you need to wire that 0 volt back to the ECU. If you don't do that, you can get you'll get faulty feedback. Basically, you can get some fault loop feedback through the frame, and yeah, it's not going to work out very good for you. So not every you need to check. So like my flex fuel sensor, I think that needs to be grounded to the frame, whereas my fuel pressure sensor needs a 0 volt. So something to think about. Yeah, keep that in mind. Don't just put everything to the frame. And yeah, that's about it. Thanks again, guys. Sorry about my horrible filming. Hopefully it's getting better. And yeah, hopefully these videos are still coming out every Wednesday. So if you haven't, like and subscribe. Any questions, if I've made a mistake about something, let me know. If you want me to talk more about the wiring process, there's so much to the wiring. I spent 2 weeks trying to get my head around what needed to be done, and probably the biggest thing that the biggest help that I did was I sat down and I did what's called a cable schedule, and this is just for the PDM, this schedule here. So this is for plug B, and basically it tells you down the left hand side there, you've got the pin numbers, you've got the gauge cable it is, the wire color. I've got the label, which is like what it's called. When it comes to programming, whether it's an output and what channel number it is, max current for that channel. I've got a column there which is actual amps. So for instance, on pin 1 I've got that's lift pump B, for the fuel lift pump. That's on a 20 amp channel, but the actual amps I've got it written down there as 10. That's probably not even correct. It's probably closer to 6 or 7. And then the destination, it's got written there water pump, but I've actually swapped it. It's actually, that is the lift pump B. It was the water pump, but yeah. So, and then on top of that, I also wrote a description explaining, because there's just so much to get your head around. Like there's 64 pins just on the PDM, and then when it comes to the ECU, you've obviously got every cable that's required for the engine to run, plus any sensors you're running for logging. There's a fair bit going on, so it does really pay to have these schedules. Also later on it will help immensely if you're ever doing any fault finding. And the other thing is, because of the type of loom that I've built, or I'm building, there really is no second chances. If you haven't got the cables in the loom, they're not going in there. Because once it's all heat shrinked up and glued, the only way to get in there is to cut the whole lot off. And not only cut it off, you'll have to probably de-pin it, de-plug it to feed on new heat shrink. So basically I'm heat shrinking this as I run it, and then once I get to the end with the heat shrink, then I put the plug on. So yeah, it is you get one chance, but obviously once it's on there, it's all nice and watertight, and it's going to give it the best chance of surviving. So that's why I've done it that way. Yeah, so really important to do a lot of planning before you just jump in and start running cables, because if you heat shrink it all up and go, oh damn, you know, I've forgotten to run 2 cables to go to this extra plug here, you're going to run into problems. So I've gone, even on each plug for the smart wire, I think there's like 6 cores that I haven't used. Now I've terminated those 6 cores, and they're going to get terminated into Deutsch plugs. So if later on down the track I ever want to get into those 6 cores and use them, those 6 channels, I can just make up a mini loom, plug onto the Deutsch plug that will be hanging out the side, and that will give me my connectivity that way, and I don't have to worry about cutting into any of my looms. So a lot of forward planning really is going to play a big part if you're unable to get in and repin and depin plugs all the time. Alright guys, that's it for this week. Thanks again. If you haven't liked, subscribed, you already said that, do us a huge favour and share the video for us. Again, any questions, post it in there. If you want to hear about something in the truck, just comment down below. And yeah, we'll see you next week. Thanks.